When working with quadratics, we've already looked at several ways to solve them, including using factoring and the square root method. However, there are times when we have a quadratic, say something like negative 3x squared plus 7x minus 1, and we want to be able to solve this if it's, say, equal to 0. It's in standard form, but if we can or don't wish to factor it, we can use a method called the quadratic formula. The quadratic formula must be in standard form to utilize it, and to solve for x, you get negative b plus or minus the square root of b squared minus 4ac all over 2a. And just like with our factoring method, the AC method, these are your A, B, and C values. Again, it has to be in standard form. There are some special pieces to this quadratic formula that I wanted to identify. The portion that is under the radical here, the B squared minus 4AC, that is called the discriminant. And there's a couple of key things you can recognize with discriminant. If the discriminant, b squared minus 4ac, is positive, then the quadratic has two real solutions. If the discriminant is less than 0, it has two imaginary solutions. And if the discriminant is exactly 0, then there is one real solution, and it happens to be located at the vertex of the quadratic. So let's do one example here using the quadratic formula. If we have 7x squared minus 2x plus 1 equals 0, a is 7, b is negative 2, and c is 1. Using our quadratic formula, we know x is this negative b, and a negative negative 2 is a positive 2, plus or minus the square root of b squared. Anytime you square a negative, it's going to come out positive, so that's 4, minus 4 times a times c, and this whole thing is over 2a, which is 2 times 7. Doing this in parts, we get 2 plus or minus the square root of 4 minus 28 all over 14. And then we can now look at the discriminant. We get a value of negative 24. And since the value under the discriminant came out negative, we know there's going to be two imaginary solutions. And this simply means that the graph will not ever intersect with the x-axis. When we factor, we pull out the I, and we're left with 4 times 6 all over 14, which we can then simplify to 2i square roots of 6 over 14. All of those terms are divisible by 2, leaving us with the solutions 1 plus or minus I square root of 6 over 7. And this here should be a 6, not a 4. Sorry about that. And so these are our two imaginary solutions.